All right, looking at 11.4 notes. I slightly fibbed. I'm sorry. I slightly fibbed. I didn't lie. I accidentally didn't tell you the truth because I forgot. Okay? So, when I was looking over these notes yesterday for 11.4, I forgot that there's kind of two sections to 11.4. The second section is putting it all together, which I told you was 11.4. The first section is finding the area of any regular polygon, which could be a triangle, a pentagon, a hexagon, heptagon, octagon, nonagon, whatever gon, because that's a regular pentagon. And I don't know how I quite forgot that, because y'all know I like to be real, right? This is the worst part of the whole chapter. Okay, just being real with you. There's this thing that's called, you see this formula right here? You see this? Okay, this is your area formula for any regular polygon. Heptagon, hexagon, nonagon, octagon, decagon, heptagon, whatever. Any of them. That's the formula. There's this terrible thing that the little a stands for, and it's called apothem. Does that sound scary?
Sounds like I'm saying possum.
Apothem. Apothem. That's what the little a stands for. The P isn't bad. P just stands for perimeter. Okay? You literally use almost something from every chapter we've covered so far in this question. Okay? So, in this example, let me zoom in because we need to get real close. Okay, in this example, inside the circle, we see that we have 5 sides, which makes this a pentagon. So find the area of the regular pentagon above if the perimeter is 60. So we have to have 1/2 a times p. We have p. We have to find the a. Okay? Now, they've worked this out right here for you, but I'm going to do it again because it's that important. So what is the apothem? You keep saying that word. What is the apothem? The apothem is any point from the middle of the shape straight down to where it's perpendicular with the side. So the apothem in this regular pentagon is AP. Okay? So what I need to find is that piece. Yes, Marshall?
Is it always going to be dashed?
I don't know. If it's not dashed, yeah, in these it looks like it, right? If you look down 1 through 6, they're all dashed. Okay? So here's the problem. I have to find what that is. And all I'm given is that the perimeter is 60. How many sides were there? 5. So if it's a regular pentagon, then all the sides have to be the same. So
Teacher Stevens, excuse the interruption. May I please have the bowling team, swimming team, the small gym, G103, for physicals at this time. Bowling and swimming team to the small gym at this time for physicals.
all of those sides are 12. How did I know that? 60 divided by 5. Okay, so if I want to find this apothem, y'all, I'm going to take this triangle right here and expand it. Okay, so what I'm about to draw, I'm just redrawing this triangle bigger. So right here, I'm going to have, so this is A, this is R, and this is P. Okay, that's all I did was make it bigger. So if this whole side is 12, what is R to P? Okay, this has to be a 90-degree angle. So, and this is what I'm finding, right? This is your X. Okay, so think to chapter 10, circles. How many degrees would it take me to go all the way around this circle right here? 360. Okay, if I drew from the center to each corner, how many pieces did I just chop this up into? 5, aka the number of sides, right? So each one of these angles is going to be the same, and it's going to be 360 divided by 5, which is? 72. So each one of these angles is 72 degrees. Which means this whole angle right here is 72 degrees. So what is this angle?
36.
72 divided by 2. Are y'all following me? Okay. So I need to find this side. I'm given another side and an angle. Can't use Pythagorean theorem. What do we have to use? Trig. Trig. Here's your angle. What's the 6 in relation to the angle? Opposite. What's your x? Adjacent. So that means we have to use which trig function? Tangent. Tangent of 36 equals O divided by A, which is 6 divided by x. When x is down low, switch them, you know. X comes here, 6 divided by tangent of 36, so x is equal to 8.26. What is x? What did we just find? The apothem. We just found the apothem. Do we now have everything we need to find the area?
Yes.
1/2 times the apothem times the perimeter, which was 60. That should give you your answer of 247.8.
Do we always use tangent?
Most of the time, yes.
Most of the time.
Because you're always going to know this angle and this side and want the apothem.
Wait, which angle?
This angle right here.
Oh, you didn't.
Oh, I'm sorry. This angle right here.
Okay.
Okay, so I know we're getting out in 2 minutes, but let's start number 1. First of all, the reason we have to use this on number 1 is because we don't know the height, right? If we knew this, it'd be a whole different story. But if this side is 14, then what's from here to here?
7.
Okay, 7. How do I find this angle? Well, it's broken into 3 pieces, right? So 360 divided by 3 tells me that this is 120, this is 120, and together these will be 120, which means my little piece is 60. Then you want to find the apothem. So you have 60, 70, and you want to find this side. How do we find A? Well, we can use 30, 60, 90, right? But if you want to just use tangent, you could just do tangent of 60 is equal to 7 divided by x. So x is equal to 7 divided by tangent, and then you'd have your apothem.
So do we just assume every time that every
Y'all can pack up.
thing is in the class?
That everything is in the circle?
I mean, like, every, polygon is in the system.
Every polygon is in the circle. I'm confused by your question.